did in its photography mission was fly some colour infrared, and we haven't used this yet, but we can see it's got a lot of potential for mapping vegetation extent. Do you want to make a comment of whether you can distinguish species from that photography? I don't think you can, but...
well, Peter gave a talk just earlier today about the MDVI indexes and how they're beginning to do that.
Okay. I should have been for the talk, clearly. Anyway, it looks like really good data, and look forward to trying to work on that. Another really important part of this whole sort of mapping thing is acquisition of ground control. Without ground control, you tend to have some quite large errors in the maps that you develop. Now BAS have got a nice system which gets quite precise GPS readings for the photo centres as they're flying, but even with that, we still need to supplement it pretty much with ground control to get levels of accuracy that we're seeking. If anybody's interested afterwards, I've got a kind of ground control field plan here which we use for the acquisition of ground control in the Dry Valleys region, just as an example of the sort of thing we might do. We're aiming to get sub-meter accuracy with these products. And one of the reasons we want to do that is so that we can overlay different data sets, put them together, and they'll co-register. We're working very closely with a group in Minneapolis on this. They're called the Antarctic Geospatial Information Center. And they've also been gathering ground control. So together, in fact, I've just come back from a week with them last week, putting all this data together into a report that will be available for the program. So this is sort of a map of the consolidated ground control points that were required in the Dry Valleys region. So this is one of our staff out in the field, and we go there because it's just really great. Nice place to go, quite impressive. This is the Upper Taylor Glacier here. And this is the boring part. After you've been into the field, you've got to compile all this information into a database so that people can use it in the future. Using this ground control, we've created a new digital photograph of the Taylor Valley, some 30 kilometres in length in the lower part. And that's accurate to less than a metre spatial accuracy, so it's improved things quite considerably. I was mentioning before boundaries of protected areas. Having created the new digital ortho, we can now map the boundaries very accurately to like within a metre. And we're going through a process at the moment of consultation on the boundaries, and we send these products out to the science community and they comment or ask for changes to the maps, etc. And we're also using it for visualization purposes. This is a perspective view created within the GIS, looking up Lake Bonny in the Dry Valleys towards the Taylor Glacier. And then the nice thing about using this is we can create a view from anywhere we want and visualize it in a custom sort of way. I mean, the alternative would be you'd have to fly out there with a helicopter and you probably wouldn't quite get the photos you wanted, and then you'd have to do it again. We can basically use this high resolution imagery and create quite realistic views. One application for that would be mission planning. For example, a lot of the time the pilots haven't been into a site before they go there. So if you want to help them to do their job and for safety reasons, you can do visualizations of the areas they've got to fly into before they go, and that can help make the whole operation a lot safer. The other thing we're doing is creating some educational products to raise people's awareness about environmental issues. And we're doing this one with Antarctic Geospatial Information Center. It's a work in progress, as you can see. We were just working on this last week. But the idea is to highlight some of the important features in the valleys. And we've used a satellite image as the backdrop, that's actually the LEMA, or Landsat Image Mosaic of Antarctica, as a base, because at this scale that's fine. And then we're kind of zooming in with photographs of the actual site, so people that are working down in this area will have their awareness raised with what the important issues are there. I'm going to slightly turn things around. Instead of talking about how we apply remote sensing in our work, I want to talk just briefly about a project which is collecting remote sensing, and where our company is involved in the environmental impact assessment side of it. The project is called IceBridge. Has anybody heard of IceBridge? Quite a few nods. IceBridge is a aerial aircraft mapping program, and it's called IceBridge because it's trying to bridge the gap between the end of one satellite sensor and the start of another. I think the new one is due to come online around 2013. But they didn't want to have a gap in the data, so they've mounted quite a large program of flying along the Antarctic Peninsula. In fact, they're going to other parts of the Antarctic as well. They're going over out from McMurdo this year as well. And they're using a DC-8 aircraft, and it's full of instrumentation, radar, LiDAR, photography. If anybody else can add to that list, but there's lots of instrumentation on the aircraft, and they need to fly at quite low altitudes as they're collecting this data. So the issue comes up as, well, what about if they're flying over wildlife colonies? You know, do they need to alter their track? So we've been involved with an impact assessment, which is looking at their tracks. I'll just skip over that. There's certain rules that exist in terms of operation of aircraft in the Antarctic, or guidelines, I should say, rather than rules. So this is the flight tracks that IceBridge projected before they went to the peninsula and did their flying last season. And we identified potential conflict sites on their tracks. And then that was fed back into the mission planning, and then they altered the tracks so that those sites were avoided, or if they were flying over them, they'd fly over at higher elevations. And then just recently we've done a post-mission analysis looking at the actual flights tracks that were flown, and identified whether or not there were any resulting conflicts, because sometimes their flight tracks didn't quite go as planned, so they altered their course or had flown lower when they didn't think that they were going to. So the idea of this is to look at, well, what actually happened, and this is high elevation and low elevation tracks. And we've actually just this week we're going to be sending the results back to the IceBridge team. It's a NASA group, and they're going to look at that and then consider how they can improve their flight track planning for this coming season. This is not Antarctica, but I wanted to just throw this in there because the other 50% of our work is non-Antarctic, and a lot of our work at the moment is in Africa, and it's specifically to support environmental impact assessment. And we're using WorldView 2 data in this case, with data that was acquired just a couple of months ago. We've presently got WorldView tasked to collect imagery in the same site. Hopefully it's going to be collected in the next few weeks. And then we use that as our base map and integrate it with all the ground surveys that are going on for the environmental impact assessment. So that's another kind of application of remote sensing with modern sensors, is for EIA work. And we haven't actually done much of that in the Antarctic, not in the true sort of EIA sense, but it has a lot of potential to help with that sort of thing. So, I mean, that's kind of an overview and summary of recent work that we've been doing using remote sensing. So, if there are any questions, I'd be happy to answer.